I need this job. This would be research with my professor, Jin Yang Lee. And you can see also in the picture. I think I was very handsome this time. Okay. I have two publications to research. When I went to Korea first, I was thinking to work only with that one, the influence of requirements as a green manual in the code production. But they say, Anselmo, no, this is not for engineer. This is for production, something like this. And then I started working this with my professor Kyungpook on for publication. But for this thesis, who was a sponsor, or for the funding, who was sponsor for this, who paid for this research is a Quaker. For this one, who paid for this research is a university under my professor. If you want to read about my research, also you can go to Google, only write Anselmo Capuchila. You can find it. Also, I can, if who want, I can provide the password, but I don't have password for this one because Koika didn't give me. I don't know why. But for this, I can provide the password, even also the link. This is my thesis topic: design and evaluation of the seeding machine. When I published this thesis also, I received good comment for the editors, and they say, "Whoa, it's a good job." Even they didn't give me any comment to correct something. Was approved the first time. I don't know if it was about the thesis or research or don't know, but I received an award. Like, I don't know, it's a like good student, but I'm not Also, I received an award for the carbon neutrality competition about the climate change. I create an idea about climate change to speak about it, to share my knowledge about climate change, and they give me also another award and a small gift. I don't know why they give small gift. That's okay. Let's go to the topic. Nowadays we are talking about climate change. We think like also we are talking about the agriculture 1.0, 2.0, 4.0, 5.0. But we are not talking about climate change. That's why my thesis also is about design and evaluate the seeding machine. But we were looking for the climate change. We know if not even know also climate change, because we know in Mozambique for one farmer to have a tractor to pay for this job is very expensive. That's why we think also we can create something with good economic viability, also for the environment. That's why we create this idea with my professor in the Department of Engineering, Agriculture, Civil Engineering. For the start the job, the research, first we start to think about how we'll design this machine. But first, we look for which kind of seeds or variety we can use. This machine, we can use a different kind of a variety, but seeds. That's why we select two seeds, two varieties of seeds, that's the corn and the cowpea. And after that, we design all the components, but looking for we evaluate the performance, spacing index, field efficiency, field capacity, even also the cost benefits. This is the conceptual diagram of the seeds, how the machines work. This machine this prototype, we can calibrate everything. Like with you, every different kind of seed, we can calibrate looking for the depth, looking for the spacing between the seeds, even also the power of who will work with this machine. That's why we have this deposit, and also we can control the depth, we can regulate the dosage of the seeds. If we depend of I call GP, but I don't know English. Poder germinativo. Em português é assim que dizem, né? Então, dependendo do poder germinativo, we can decide how many seeds we can use. Also, we can calibrate for 2 seeds. Also, we can calibrate for 1. Depend of the quality of the seeds. This first we try to measure the difference of the seeds, because this will decide how we can design our seed distributor. That's why we use 2 varieties, corn and cowpea. But we can see there in the notification pan and easy. This is Mozambique seed. I took this seed when I was going to Korea, but not for experiment, for it. That's why I decided also, I can use this kind of seed because it's very accessible in Mozambique. We can find it any site, everywhere in Mozambique. Even the farmer will be easy to find this kind of seed. After that, we calculate the diameter, geometric, volume, and sphericity to see how the seed will shape. That's why we find 18 and 14. That means the seed have a sphericity shape. To see if you will have more damage or not, or we can put in the soil or not. That's why. Okay, this is a design. That's why I was talking about. You can see here. This is depth regulation. We can calibrate. You looking for the agro characteristics of the seeds. Also, we can calibrate the full open or the full cow. Como vou dizer, nós podemos calibrar todo o sistema, podemos regular a profundidade, podemos regular também o abridor de surco, como também o tapador de surco. Nós temos, we have like 2 wells, one is dependent, one is independent. O que acontece aqui é que fica de forma fixa, outro é móvel, para facilitar o agricultor quando quer trabalhar com a máquina, poder dar aquela curvatura, also would be very easy. Cannot spend more power for working with this machine. This is a seed distributor. We thought like we work with some partner in Korea. They told us we can try to find some kind of seed distributor that can be easy to find in Mozambique. Also will be recovered. That's why I think like, okay, I can use both. That's why it's very easy to find. Also, it's very easy to recover. Also, every good resistance capacity resistance. Use this kind of the seed distributor. That's why we try to calculate the number of holes, the diameter, also the distance between the plants. That's why we can, if you want to use any kind of seeds, we can calibrate how many scroll you can calculate this distance between the seeds. After that, this is a well. We have 1 and 2. One well is a principal, this is a guide well. Temos uma roda guia, outra é auxiliar. Que aquela é muito mais para garantir a sustentabilidade ou aquele todo o sistema de movimentação da própria máquina. Enquanto este aqui é aquele que é conectado diretamente com a distribuidora de semente. And then we try to calculate the perimeter, also diameter, and number of spoke. But the problem is like, the distance between the spoke should be the same. If you use like 5 centimeters between, all the distance between the spoke need to be the same. After that, this size is only for control. If you were working with some salt have more compaction, that's why we can use. That's why I use that Mozambique nós chamamos para não patinar, né? Esse dizem. Para não patinar, então, em qualquer condição de solo, se o solo tiver muita água, ou se tiver mais úmido, quer dizer mais úmido, então é necessário usar esse tipo de sistema para garantir que ele não pudesse patinar no solo, pudesse entregar a semente em distância desejada. This is a full open and full cover. We can see this is for open the line. This side is for open the line. That one is for cover the line. But we can see the angle. This is because if you use this under 7 this angle, this means they can have good facility to penetrate the soil. Also, that one they can cover the line very well. They cannot put more soil up to the seeds. This seed tank and chassis, also all the things is connected, but the first we try to design the chassis, because the chassis will be, we need to find which kind of material we need to use. We need some kind of material to be the good resistance for all the force of the seed tank, or if you put the seed on the seed tank, if you will damage the chassis or not. Isso muito mais para garantir com que nós podemos decidir qual tipo de material nós podemos usar para o depósito de semente, para garantir com que o chassis consiga resistir todas as forças que é aplicado no próprio chassis, como também para facilitar o uso da máquina. After that, we have learned the seed machine, looking for the percent of seed damage, seed spacing assessments, also the efficiency and the field capacity. After that, we did the economic analysis to see if this prototype will be a good economic sustainability for the farmers or not, will be expensive or not. How much they can have in 5 years. That's why we saw it's very important to try to calculate the economic, to see the economic analysis, if they have a profit, the farmer will have a profit using this machine or not. This results in discussion. The machine, they can work 6 walls per minute. Also, we try to analyze on the 4 percentage of the seeds, 25%, 50%, 75%, and 100, to see what will happen if you put all the seed on the storage. Also, how we can, if the seed will have 2 seeds or not. Muito mais para ver se haverá 2 sementes entrando na distribuidora de semente ou não. E daí nós verificamos que, afinal de contas, nós podemos somente quando nós aumentamos a quantidade de semente. O que acontece? Há momentos em que há entrada de 2 sementes e outras também não. After that, isso é mais engenharia. Então, depois disso, nós calculamos qual é a força que é aplicada tanto calcular as forças de transmissão na parte horizontal, na parte vertical. Na parte vertical, quando nós after we put the seeds, how will be the resistance of the machine? The vertical side, we can see the force, how the people will use this machine, how many power they will spend to work with the seeding machine. We calculate also the seed damage, how many kilometer velocity we can use. That we saw if we use after 4 km per hour, what happened? What is happening? The seed will damage. That's why we found like if you try to walk one speed of 1 kilometer, 2 and 3, we cannot find more damage on the seed. But we saw only for corn because the first shape also my professor said maybe because of the quality of the seed, but I'm not sure. But after that, we analyze the seed spacing index, the seed spacing analysis, and depth to show how will happen. Also, we can use after 5 kilometers per hour. How will happen? They will change the space or no. How also will be the depth? The depth will change or no. If you apply more velocity, what will happen? The depth will change also. Some seed the machine cannot put on the soil. This is about the economic analysis to see how many hectares the farmer can find the balance point or the profit. That's why we find in 2.2 hectares the farmer can recover the investment. That's why we spend around $1,200 for manufacture this machine. We didn't only design, we built this machine. We have this machine in Korea also. That's why we spend that money to make this machine. But I didn't put the photo here. If you want to see, we can go to the armor. We can read also. Or who want to read all my research, we can send message or message me. I can send to you guys. This is my conclusion that I say if we increase the velocity after 5 kilometers, what will happen? They interpret the distribution of the seed. Also 1 to 2 kilometers, we can see the seed damage will be below or we can do the seed damage. Also, we can have a return of investment approximately 122 hectares, and thank you.